Right, so welcome to video 5. Sorry, I said in the last video that we wouldn't be doing anything else out of tutorial 8. I'd forgotten about the ANOVA question, so we're going to do that here. Some people also asked me to explain about the Mr. Jones question with the pigs. I'm not going to go through it in detail because it's mostly based on theory and logic. But what I can say is that the principle you need to take away from that question is that Mr. Jones was wrong in assuming that a high heritability value means that external or environmental factors won't change the variation you see in the phenotype. That is wrong because there's no way to measure the magnitude or to predict the magnitude any kind of environmental factor will have on the variation in phenotype between generations. Also, you cannot trust the value that was given by that was calculated by Mr. Jones, because that value was calculated with a population that had all varying environmental factors eliminated, and that were all closely related anyway. So it's used with one population with only one environmental factor. Whereas to get an accurate reading, you'd have to take from multiple environments under multiple environmental pressures. So that's all I can tell you. Right, so with the ANOVA question, which was it? It was question 7 in tutorial 8. It states that 6 sires, or male pigs, mated each with 3 dams, female pigs, and each of the dams produced 9 offspring. And it gives you a table with the phenotypic values of weight gain in the first week of life of the piglets, and it wants you to use those values to work out the heritability of that trait, weight gain. Now, the first thing that you have to do is you have to understand that you need 3 sets of values. So in the table given to you in the test, you get a column for your sires, which are A, B, etc. Your dams, 1, 2, and 3, each of those which mated to that one sire, so 4, 5, 6, etc. And then the offspring values, so we'll call them piglets. And each dam had 3 children, 3 offspring. Okay, so there should be 9 values per sire. And those are the phenotypic values that we are going to use in this for this question. So the first thing you need to do before you start is you need to add up and find the mean of each sire of each of the pigs, you need to find the mean of each of the piglets associated with each sire. So for sire A, you would have to add up. I'm going to use the values from the table given in the question. You'd have to add up and find the average of 4.8, 4, 3.8, 4, 3.2, 3.5, 3.2, 3.7, and 3.5. Okay, so you'll have to do that for each sire, and you will get your average value. Then you will have to do the same. Okay, so this will be from A to F, and then you'll have to do the same for the dams. So that'll be 1 to 18. Remember, there are 18 dams because 3 dams each were mated with one sire. And so you'll have to find those values. So we'll call these the sire values, and these are the dam values. Okay, I'm not going to bother writing numbers, otherwise we're going to be here all day. So that's the first thing you need to do. Then you need to understand what the question is asking you. The question is asking you to find the heritability, or the narrow sense heritability, which is your h squared. And to calculate that according to this type of question, we are going to use this formula, which is the standard deviation, the variation of size times 4 over the total variation. Okay, but we don't have those values. To calculate those values, we need to use an ANOVA table, which looks at the source of variation between the sires, between the dams, and within the progeny. Now, I'm not going to try and explain those concepts too much because it'll confuse you. And also, you can just read up on it. It's very important that you do at some point because it kind of explains the whole logic of this kind of process. But I won't do that now because you just need to learn how to do the questions. So the first thing we've done is we found the sire values, the dam values, and we have the piglet values, which were given to us in the question. So now we're going to start doing our big calculations. The first thing we have to do, actually let me just draw this diagram so that you can see how we're going to relate all of these things. So here's your sire, your dams. Each sire was mated to 3 dams, and each dam had 3 piglets. So the easiest way I can teach you this, without making it too specific to this question, is that there are 3 tiers. Here is the first tier, the second tier, and the third tier. Okay. And that's how we're going to divide up, or how we're going to partition which aspect of variance we're looking at between, within, and all that between those groups. Okay, so the first thing we're going to calculate is our correlation factor, or our CT value. Most of you have heard of it before. And to calculate that, I'm just going to write down, for now, I'm just going to write down the formula to calculate these things, because writing down the full answers is going to take forever. So to calculate your CT value, we're going to calculate our x squared values, the summation of the x squared values. We're going to add up all of our piglet values, all of them, all 54 of them, square it, and then divide it by the total number of piglets, which is, just so you know, 54. Okay. Then we're going to find our first sum of squares, which is our total sum of squares. This is now, we use that to we use a similar situation now. We find the summation of the x squared values, and we minus our correlation factor. Now, it is very important that you don't get muddled up between these two values. Here, between this and this, they are not the same value. Here, you add up all the phenotypic values, then you square it. Here, you take each phenotypic value, you square it, and then you add them all up together. So that's what you're doing here. Then you find your sum of square for your first tier. I'm just going to write here first. In this question, that is our sires, because they are on our first tier. So I'm just going to write first for now, so that you can use this kind of formula later. To calculate that, we're going to take the summation of the sire values, squared. So we're gonna square the sire values, and then we're going to add them up, and then we're going to divide by the number of offspring per sire. Now each sire, sorry, there's a mosquito, each sire produced 9 offspring. So here it's going to be, it will be 9, but I'm just going to write here offspring per sire. Alright. All of this minus our CC value. Then we're going to find the sum of square for our second tier, which is similar to this equation here, except we're looking at the dams. So it's going to be the sum of the dam value, the squared dam values, and then the number of offspring per dam. Now we know that each dam produced 3 offspring. Okay, minus this value here, which is our, I can't remember what it's called, but it's something to do with an uncorrected value. I don't have the original notes, so I'm sure most of you have heard of that before, so you need to look that up. So it's the summation of sire values squared divided by the offspring per sire. Okay, and that is your sum of squares for your second tier. For your third tier, which is looking at your piglets or your offspring, that is considered our within value. So we also call it sum of squares within. And that is just the total value minus the sum of squares for the first tier and the sum of squares for the second tier. So whatever sum of squares is left after we've added this, considering that this is the total, that will be our third, our sum of squares within. Right, now that we have those values, we can create an ANOVA table. Now the biggest part that you need to remember for the ANOVA table is that you have the variation is okay, so you need to understand how to draw it. So the first thing you're going to do is the sources, of variation. I'm just going to write V. Okay, so you're going to find the sources between, or define the sources between the individuals in the first tier, or sires. You're going to find the differences, the source of variation between, the variation you see between the individuals in the second tier, which is your dams. This is also considered within sires, because any variation you see between here is within one group. Right. You don't need, I'm not going to explain it further because you can look it up online or whatever, and that's something you need to come to your own realization of, because it's a bit complicated to visualize. And then you have to look within the third tier, or in this case, the progeny. Then we're going to have a column for our degrees of freedom, our sum of squares, and then our mean square value. Your degrees of freedom are very, very important, and a lot of people just think that degrees of freedom is the number of values minus 1. It's not. The way it works technically is the number of values minus the number of categories. Okay, so in the first tier we have 6 values because there were 6 sires. And how many categories are there? There's only one category. There's only one set of sires. In the second tier, or the dams, we know that there are 18 dams, but there are 6 categories because 3 dams went to 1 sire, of which there were 6. So we have 6 categories. And for the offspring, we have 54 values, and there are 18 categories because there were 18 mothers. Okay. And then here in your sum of squares section, so let me just cordon that off, we will include our sum of squares for the first tier, which we calculated before, second tier, and third tier, which we have all already calculated. Then the mean square is simply your sum of square value divided by your degrees of freedom, and that's the same for all three categories. Okay, so your actual, sorry, didn't mean to put that out of the way. Your actual table is relatively simple to do. The next step is that we have to start calculating our variances as in order to start looking for the values that make up this equation. So, first thing that we know for sure is our variance of our within value, or our progeny, or our third tier, okay, however you want to talk about it, and that is this value here. Okay, so that is equal to your MS of your third tier. Okay, the next we do the dams, or the second tier. So actually let's just write your third tier, sorry for the scribble. Alright, that variance is calculated by the, so let's write it over here. It's calculated by the mean square of the second tier minus the mean squared of the third tier, all over the number of offspring per dam. We say per dam because that is the second tier, and that's what we're looking for here. Number of offspring per individual in the second tier. And then we do a similar thing for the first tier, which is the mean squared of the first tier, first tier minus mean squared of the second tier over the number of offspring per first tier individual, which is our sires. Right? Then we have our total value, which is all of the above just added up. So first, second, third. Okay, and then we calculate our h² values by substituting into the formula 4 times your first variance, your first tier variance over the total variance calculated. And that's all there is to it. I hope you can see that. Alright.